Hi, everybody. Welcome back to the Feynman Technique. I haven't done a things we take for granted video in a while, so I figured I'd do one today since I use this formula stated right here very frequently in my videos. So I just wanted to kind of make a refresher, give you guys a refresher on why this is true. Um, or maybe you're learning it for the first time. But anyway, this is one of the most famous identities in all of mathematics, and it's really pretty cool if you think about what it says. Um, this taken by itself doesn't make a whole lot of sense until you see it. Don't forget, I is the square root of -1, which is, I mean, up until the point you learn about complex numbers, that's nothing. I mean, it doesn't make any sense. There's no number that you can square to get a negative value. But it's going to make sense by the end of this. Okay, so we're going to need three things. The first thing we're going to need is the Maclaurin series representation for cosine x. And you learn about this in calculus BC if you're in high school, or you'll learn about it your first year in university for a typical calculus curriculum. All right, the second one we're going to need is the Maclaurin series for sine of x. And the third one, of course, we are going to need the Maclaurin series for e to the x. All right. So again, we're going to define this constant I to be the square root of -1. Therefore, I squared is equal to -1. Again, if this is the first time you're learning about this, this doesn't make any sense. Just go with it. Basically, mathematicians made up a number I that is supposedly equal to the square root of -1. Okay, so from here, we're going to plug in Ix into our Maclaurin series representation for e to the x. And this is what we get. We just replace our x with an Ix and then use the properties of exponents to split it. Okay. So the next thing we're going to do is we're going to write out the first 9 terms of the Maclaurin series for e to the ix. And this is what you get. You can see this is Rn is equal to 0 term, 1 term, 2 term, 3 term. And we went all the way up to the ninth term there. Okay. Next, let's show that 0 factorial is equal to 1. Well, we should know this. N plus 1 factorial is equal to n plus 1 times n factorial. That's the recursive definition of the factorial identity. Okay, now if we replace n with a 0, what we get is that 1 factorial is equal to 1 times 0 factorial. Isolating the 0 factorial gives 0 factorial is equal to 1. And we needed that just in case it wasn't, clear why we can say that 0 factorial is equal to 1. That's why. Okay. So next, what we do is we're going to kind of clean this up a little bit. We're going to, we're going to clean that up. So for this first term, we end up with just 1 because we know 0 factorial is 1. And then anything raised to the 0 power is also 1. So this first term is just 1. Okay. And then our next term becomes, well, I to the 1 is just going to be I, right? Times x to the 1, which is just x over 1 factorial. And I left 1 factorial alone. Okay, our next term, we have an I squared. Remember, I squared is -1 because we defined I to be the square root of -1. So this term right here just turns into minus x squared over 2 factorial. And then don't forget up here, what we really have here is an I times I squared. and I squared is -1. So we end up with minus I x cubed over 3 factorial. And then what we have here really is I squared squared, which is -1 squared, which is just 1. And the pattern continues from there, and this is what e to the ix equals if you expand it out term by term for 9 terms. All right, now we can actually, let's isolate all the parts of this that have an I as part of them, and all the parts that don't. So these are all the parts without an I, and these are all the parts with an I. And now you'll notice this is exactly cosine of x. This is the expanded version of the Maclaurin series for cosine of x. So what we have now is that e to the ix is equal to this, and then right here I just factored out an I. And this is the expanded version of the Maclaurin series for sine of x. So I'm going to put them back into their Maclaurin series representation. You can see if we continued this on and on forever, the pattern that emerges is this. This is what we have. And same for this. If we continued this pattern out, what we would end up with is this. Again, this right here is the Maclaurin series for cosine x, and this right here is the Maclaurin series for sine x. So finally, we can see that e to the ix is equal to cosine x plus I sine x. All right, guys, hope you enjoyed that, and we'll see you next time.